Hello everyone. I'm going to continue talking about list comprehension actually today. Uh, List comprehensions are a powerful syntax for constructing lists, and the basic kind of syntax will be something like this. So imagine we are creating a new list, and we can use E of E for I in E of I, sorry. E of I for I in the list that we had already. Imagine the list is already defined of some elements, for example, right? Okay, so what this does, it will create each element of new x for I that is going to be the number of elements in the previous list. It's going to go to the list, get that element and apply the change and make a new element for the new list. So we are going to talk about list comprehensions. Okay, so let's say we have a list here, and let's call that L, it's better. 1, 2, 3, 4, 5, and 6. Let's say we have 6 elements, right? And then I'm going to print L, and then I'm going to make a new L. This is, let's say, L new, right? Is equal to, I'm going to say I multiply I for I in L. And then I'm going to print L new. So when I apply this, when I run this command, see what happens. So L was all like 6 elements, right? The I will be the number of elements in the previous list, right? It's going to get the first element and multiply it to itself because I is still 1, right? And then it's going to transfer it to a new list. And then now it's going to get the second element, multiply it to itself, which is the current element 2, and then it's going to give 4, right? And then the next element will be 3. I will be 3, right, from here. And then it's going to say 3 multiplied 3 is going to be 9, right? So I is the element inside the list, right? And how many we have? We are going to have 6 elements of the previous list. So maybe I should will be the element of the original list and will be 6 of them in this case, right? Okay, so we can do something else. We can say, for example, 5 multiply I. So it's going to get the element in list, original list, and every time multiply that element to 5 and create a new element. Look at this. 5 multiply 1 is 5. 5 multiply 2 is 10, and so until the last one, 5 multiply 6, right? Okay, so this is the kind of easiest form of creating a new list based on the previous list. So now let's say we have a list L1 equal to negative 10 plus 5 multiplies to I for I in range 0 to 10. Do you remember range? So this is your participation point here. Explain to me what is range and what does range do, and also how many elements can it have. So this will be your participation point for this video. Okay, so we have a list created in this way, right? And now, because we are not getting information from any existing list, we are going to use range, which is going to create some numbers for us here, right? And then we are going to print L1, and then what we do, we create L2, and then this time let's say -20 plus 5 multiplies to I -10, because I want to be almost similar to the previous one. So for I in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this one is exactly as this one, right? So now let's see what is the result of the second list. They are identical, right? Even though I had different kind of a list of number here, I mean the way I wrote down was different, but still, because the numbers that are created in this list is exact same as this one, the outcome will be similar. So it's going to get numbers from this list, 0, 1, 2, 3 up to 9, right? And then it's going to multiply each of them by 5, and then subtract them from 10. So 0 multiplied 5 is 0, minus 10 is -10, right? And then 1 multiplied 5 is 5, minus 10 is -5, right? You see that in this order, it's going to generate a new list for us. Okay, so what if we want to, actually let me create something that is like this. For I in range 0 to 10. So what this does, this will get the range 0 to 10, and then for each of the element in range, it's going to just print that element, right? So print the elements for each elements in range 0, 9 gets the element and print that element, right? So this was a kind of easy form of using comprehensions. Okay, so I think we talked about sorting the list, but just to be safe, to sort the list, we can use sorted, and in this way, right? What did I do wrong? Oh, sorry. What I should do, this one doesn't have ed. So for the list, we use sort only. Okay, good. Versus this one. Okay, so I'm going to write down, make it clear. Sorted versus sort. Okay. So I could use sorted in this way. Sorted L, right? So this is the way we use sorting list. Well, the reason here it says none because it's already sorted, right? So there are two different ways to sort. One is dot sort, which is one of the attributes of list. Use list, which is one of the attributes of list, right? But this one is a built-in function that you can use to sort any set of number. So let me make okay, so now how can I know if list is sorted now? I'm going to print to know if the list is sorted. Okay, good. So we can print it in this way and it shows if the list was sorted using dot sort, right? Okay, so what is the next topic? So nested list. Let's talk about the nested list. So the elements of a list can also be lists and allowing kind of multi-dimensional data set, and we can achieve that in this way. So let's say L nested. We can use one whole bracket and then let's say we have element and then we have another set of element here. So one list and then another list. We already did that with array, multi-dimensional array, right? But for multi-dimensional array, we had the same number of elements in the first array and the same number of elements in the second array, right? But list is different. You can store different dimension in each list, nested list. So let's print this. So now we have two lists stored in one whole list, right? And then what we can do, we can print elements of this nested list. 0 shows us the first list, right? 1 shows us the second. So only one bracket help us to extract the information of each nested list. And if you want to get each element in the list, let's say I want to get the first element in the 0th index, so will be 2, means like this one. So So 0 in nested list 0, and then nested list index first, index works, right? And then what this one does, it gives us index first element, index first of nested list 0. Okay, good. And then let's say I want to get the first element of, this is first index element first nested list index first. Okay, good. So means this one, right? So this is about indexing nested list. And then so in place modification of list, let's talk about this one now. In place modification of list, okay, we can use append using dot append to append a single element to a list. This is very useful when we want to use for loop, and for example in for loop we are able to create an empty list, and then in each iteration or loop we can add a new element to the list, add a new element until we store all the element that we are generating in the empty list, in the initial empty list. So let's see how we can do this. So you can use append to add a single element to the list, right? So let's have an example. Imagine our list is equal to 2, 3, 4, 5, and then we want to print this to know exactly what we have, and then we can say, we can append a number, for example 88, to the list, and now print the new printed list, original one, to see what has changed. So this one will help us adding 88 to the original list. It will add it to the end of the list, to the end of the list. Okay, and let's print it. Okay, good. So you will see 88 is added to the end of the original list, right? And then what else we can do? We can use L plus equal this one. I think I talked about this one a little bit too. Let's say 77, 88, 99. I'm going to add these values to the list by using this one. See what happens. So now we'll see all of these are kind of concatenated to the original list. Concatenating the new list to the previous or to the original one, right? Original list. Okay, so that's it about, no, we have more about actually list. We have insert also. What insert does, let me, so what insert does is inserting element into the list at a certain index. So we can insert an element to the list at a certain index I, for example. So how we do that? Dot insert I and X, for example. And then in here, index I, adding element X. Okay, so now it's more clear, right? Okay, so how we do that? Let's have a list here, and then I'm going to use L dot insert and parenthesis, right? I'm going to add element 19.5 to the, which one? Third element, right? Third index. So this is going to be third index, and we are adding element 19.5 at this one, and then we are going to print L. As you see, at location third, we have the element 19.5 added to the list, right? Okay, so now what else we want to do? We want to adding actually okay, so let's talk about this one. This is a kind of new modification. So let me have 1 2 3 4 and y is equal to another list 5 6 7 8, right? And I'm going to create z equal x plus, actually no, this one, x and y, and then let's see what z becomes. Okay, so this is a nested list, right? This one creates a nested list from x and y, right? And then we want to see what append does to the x and z. So if I say x dot append element 99, right? And then I'm going to print x. We already know x was 1 2 3 4, right? And then I'm going to print z. As you see, this changes, append changes x in place and changes x and z in place. So remember, this action will modify both x and the nested the new nested list. Okay. So what else? If I create this one again, I want to try, do you remember? We could use this one also, this method also to concatenate, right? Let's see. I'm going to concatenate some element to X. I want to print X and also print Z to see how this is affecting both X and Z. Okay, so here also we see plus changes X and Z in place. So both of them will change X and Z in place, right? Okay, so the new topic that we are going to talk about are the tuples. Let me write down tuples, which are data structure for storing multiple elements in order. The elements can be accessed via indexes into the list, but the length of the tuple is always fixed, So unlike in other languages, actually the elements don't even need to have the same type. So to store tuple, so element don't have to have a same type, and also tuples also can be nested as well, like list. And the basic tuple can be like this: t equal to 1 and 2. Print t, and then let's see, print the type of t in this way. This is a tuple, right? So we use parentheses to create a tuple, and then the nested tuple will be something like that. T nested can be 1, 2, and then 3. Actually, let me put another number: 5, 7, 8, and 11. And then let's print it t nested, and then printing the type of t nested. So let's see what we have. So this is the nested tuple, and the type is still tuple. Well, what we can actually talk about all the properties and indexing of tuple also. Okay, so indexing. So imagine we have tuple equal to 1, 2, 3, and we want to see what is the T0. Well, this is similar to before, right? And this one. Oops. -1 is going to be the last element. Okay, great. So this is similar to the indexing we had before. So now a new thing. So let's say we have a tuple like this. Let's see if we can change an element using indexing. So print. We cannot do this in arrays, but let's see here. So we cannot actually, we should be able to. Why not? That's very interesting, because we could do that before. We were able to do that before. That's very interesting. So now we cannot do replacement. Okay, so we are not allowed to replace elements in tuple anymore. Oh, I'm sorry. Yeah, in list we can do that. Let's see. Let's try. If I have a list 1, 2, 3. Oh yeah, okay. So let's change this to L. Yeah, I know in either of them we can do replacement. So we are allowed to replace element in list, but if we have tuple like this, that was good mistake, because I even don't remember if I talked about replacing element in list. So in tuple we cannot do this. We are not allowed to replace element in tuple. Okay, good. So it doesn't work in tuple, but we can modify it. How we can modify it? There's a way to do this. So let's see how we can do this. So let's say we have tuple. Oh, actually, let me talk about something else before modifying the element in tuple. So let's say we have a list here, 1, 2, 3, and then now we can create a tuple of L1 and L2, which both are the list, and then print tuple in this way, right? So now we are able to append. Now here we can do append and indirectly change the elements of the tuple. So I'm going to add an element 99, for example, to the first list, and then let's print L1, and then now this is going to affect on the tuple that we created. Look, so we can indirectly modify the tuple if the elements are modifiable. Okay, so here what we were doing, creating a tuple using two lists. Okay, great. Okay, so let's say we have L1 equal to 3, 4, 5, 6, and then L2 equal to 9, 8, 7, 2, And then we are creating a tuple using the zip function, which returns an object. So let's see what zip does, and then I'm going to talk about how to fixing and creating a correct way of combining two lists to a tuple. So we can use zip to combine these L1 and L2, but if we just use zip, it's going to print in kind of only the address of the object. This only prints the address of the object. So the way we are going to modify and create a tuple using zip, and actually this is kind of interesting way of creating and combining two lists, two lists. So we are going to use list of zip L1 L2. So now see how zip will create a new tuple for us in this way. So it's going to combine these two, these two, these two, and these two, and create order pairs for us using list 1, list 2, and create a list for us. So it combines two lists L1 and L2, creates pairs, tuple pairs, and store them as a list. Okay, so this is also a useful method if you want to create order pairs of some elements. What else about the tuple? So we talked about appending. I think that's it. These are all about the list, and I'm going to just ask you a question for participation point. So imagine if we have x equal a list 1, 2, 3, and I have a y equal a list of x. So what is the outcome of y first? So what is the outcome of y? Then I want to know if I do append x in this way to some element like 5, 6, 7, how does it affect y? Okay, so this is the second participation point for this lecture. We'll see you later. Take care of yourself.